Hello, my name is Hemant Kumar. Today I'll be presenting my project Hybrid Movie Recommendation System, Enhancing User Engagement for Streaming Platforms. The project aims to tackle a key challenge in the entertainment industry, keeping users engaged through the personalized movie recommendations. Streaming platforms like Netflix face intense competition. One major challenge is ensuring users stay engaged with recommending movies they'll enjoy. The objective of my project is to develop a hybrid recommendation system. This system combines three methods. Popularity-based filtering is to recommend trending movies. Collaborative filtering to suggest movies based on the user behavior. Content-based filtering to recommend movies similar to those the user has liked. So by integrating these methods, the system aims to enhance the user retention and watch time. For this project, I used Movie Lens ML latest small dataset from GroupLens, which is widely used in recommendation system research. It includes around 100,000 ratings, 9,000 movies, and 600 users. I utilized two main files. One is ratings.csv and movies.csv. I started with exploratory data analysis to understand the dataset. This plot shows the distribution of ratings across all the movies. As you can see, ratings are skewed towards the higher end. Most users tend to rate movies between 3 and 4.5. That we can see from the graph. This bias is important to consider when building the models. Next, I analyze the average rating per movie. This plot shows that while some movies consistently receive high ratings, most hover between 2.5 and 4. That we can see from this graph. Finally, here I examined the relationship between average ratings and the number of ratings. Interestingly, popular movies with many ratings don't always have high ratings. This supports the need of hybrid approach that considers both popularity and user preferences. Finally, I looked at the distribution of genres. The most common genre are drama, comedy, and action. This analysis informs the content-based filtering approach by showing which genres are prevalent. I am pre-processing. I implemented weighted ratings using IMDb's formula, which balances movie quality and popularity. This ensures movies with more ratings have a higher influence. I also applied one hot encoding to genres, allowing me to use genre data in machine learning models. For classification, I built a logistic regression model to predict whether a movie is slightly rated. That means average rating should be greater than 3.5. I used number of ratings and genre features as inputs. The F1 score was used to evaluate the performance. After tuning hyperparameters with grid cells, the model improved from 0.72 to 0.78. As you can see the confusion matrix here. Next, I implemented collaborative filtering using SVD, singular value decomposition. SVD captures latent patterns in user preferences and movie attributes by factorizing the ratings matrix. The model achieved an RMSE of nearly 0.88, indicating good accuracy in predicting user ratings for unseen movies. For clustering, I applied k-means on genre features to group similar movies. The Silote score was used to evaluate clustering quality, achieving approximately 0.23 for k equal to 5 clusters. This score suggests a moderate separation between clusters, which can be improved in future. The cluster distribution plot shows the number of movies in each cluster. Here are the top 10 movie recommendations for a specific user using SVD model. These recommendations are purely based on users' behavior and rating. Let's say this is user 4. His movie preferences will be Inception, Graduate, Shawshank Redemption, Lord of Rings, etc., etc. And the hybrid recommendation system combines collaborative filtering, scores, content-based similarity, popularity score. The final score is a weighted average, 40% collaborative, 30% content based, and 30% popularity based. So this balance personalization and trending content. So the hybrid system offers strategic benefits, delivers personalized and popular recommendations, increases user engagement and watch time, supports genre-based marketing through clustering insights. This can help streaming platforms retain users and boost revenue. To conclude, I successfully built a hybrid movie recommendation system that enhances recommendation quality by integrating different techniques in future. I plan to incorporate user reviews and tags for richer content features, explore deep learning approaches like neural collaborative filtering, integrate temporal dynamics to account for changing user preferences. So now let's move to our code. This section of code is where I build the recommendation models. We'll look at how we pre-process the data, create features, and train our models, and finally evaluate the results. So these are the libraries for data. These are the all the libraries that we have used for the movie recommendation system pipeline. And Pandas library, NumPy, Matplotlib, Seaborn, Surprise, dataset reading, and SVD, etc. Sklearn, all this, Sklearn metrics. Here we have loaded our datasets, both of the movies.csv and ratings.csv, and we have started our exploratory data analytics here. These are all these graphs I have explained in the PPT. So as part of data pre-processing and feature engineering, the block code is responsible for encoding the genres of movies into numerical format so that we can use them in ML models. We use multi-label binarizer from Scalar library to perform one-hot encoding, which converts each genre into a binary feature. This is important because many machine learning algorithms cannot handle text directly. For instance, if a movie belongs to genre action adrenaline, this step will create two columns for each genre and populate them with 1 or 0 based on the movie genre. Popularity-based rating calculation. So since we have this plot is the movie sorted based on the weighted rating that we have calculated from the number of ratings. This part of the code calculates the weighted ratings for movies using formula inspired by IMDb. The formula balances both between average rating of a movie and the number of rating it has received from different users, giving higher weight to movies with more rating. This ensures that movies with only a few ratings but higher average scores don't match the recommendations. So we filter out movies with fewer than 75 percentile of rating to ensure only popular movies are considered. Here we used logistic regression to classify movies as highly rated or not based on features such as number of ratings and genre encoding. The target variable y is whether the average rating of the movie is greater than or equal to 3.5. We also perform hyperparameter tuning using grid search CV to find the best regularization parameter and penalty type L1 or L2. This step helps improve the optimization of model's performance. However, classification report before and after has not changed a bit. So this is the confusion matrix that we have obtained for our classification model. This section implements, for collaborative filtering SVD, this section implements a singular value decomposition for collaborative filtering, which helps predict ratings of an unseen movie based on the user interaction. We use the surprise library that we have declared in the starting, imported the surprise library in the first code here. The model is evaluated using RMSE, root mean square error, and an average RMSE score is calculated from a five-fold cross-validation, which gives us a sense of model's accuracy in predicting ratings. The next, we applied k-means clustering to group movies by genre similarity. The k-means algorithm divides movies into five clusters based on their genre features. To evaluate the clustering using list or score, which tells us how well the movies are grouped, a higher score indicates better clustering. Since we got 0.2064, it is not that bad score. We can use this for the clustering. For our hybrid recommendation system, this is our user preference based recommendation system. Based on users' likes and whatever he has watched before. So this one recommend movies SVD will recommend the movies based on his like genres. And now here the hybrid recommendation system. For our hybrid recommendation system, we combine the scores from all three methods, collaborative, content-based, and popularity-based filtering. We compute a weighted sum of three scores, where the collaborative score contribute 40, content scores 30, which ensures a balance between personalization and content similarity. These are the movies that we got as recommendations. So finally, the recommendations are evaluated and we present the top 10 recommendations for user 4 based on our hybrid system. So these are the top 10 recommendations for user 4 based on the hybrid system. The hybrid system provides a diverse set of recommendations balancing personalized user preferences. However, balancing personalized user preferences, content similarity, and popularity, which is essential for enhancing user engagement and satisfaction. With this approach, the system effectively balances personalized recommendations with content diversity and general popularity, addressing key business needs such as user retention and increased watch time. In future. We can explore deep learning models, incorporate user integrated content, and track comparable changes in user preferences. Thank you. Thank you.